So, hello, my dear student. How are you? I hope you are well. Today, I'm going to start lecture number six. So, dear student, in lecture number, we are going to discuss. These are our subtopics that we are because of continuous trip, continuous this continuous without built up, right? So, let's start today's lecture. So, cause of shift, right? My dear, if you talk about the ductile, basically ductile material, right? There is a yielding. There is a thing in, right? There will write down there will be thing ductile, right? Ductile. A ductile material. What now? If you talk about the brittle material, here the brittle material, there will be a brittle fact, brittle material, right? There will tell, there will be brittle, there will be a material, right? My dear, let's come to the ductile because the failure of the ductile. So let's discuss. This is the first piece. Now let's discuss the ductile. Here I'm going. Here I'm down. Right. Topic that mechanism of formation. It's better that I will start mechanism, mechanism down here. Mechanism of chip formation, of chip formation, chip formation in ductile, right? In ductile, right? Mechanism of chip formation. So what is basically going? Already we understood. Already we understood. Took the machine, right? And have seen there will be here you can see the chip, right? Now, my dear, if you go into the shear plane, right? Basically thickness, shear zone. This shear plane has some thickness, right? And the approximate thickness shear zone or one tenth, okay, one tenth of the tenth. The thickness of the shear zone, thickness of the shear zone. Write down thickness, thickness of shear zone, of shear zone. Basically, it is what? One tenth of shear plane, shear plane, shear plane. So if you go into the shear down, let me draw here. Let me draw here. Draw a shear plane, shear zone out this, right? Shear zone I'm talking about. What is going to happen when you are going to apply the act? What this is the actual force when you apply, right? So in this zone, what happen? A compression is right. A compression is this, and because this zone is going to be compressed now, so equally a equal reaction force is also comes. So what is going to be happen? Basically, this reaction is comes from workpiece side, and this action is coming from tool in this zone. So what is going to be almost basically material almost subjected to compression. Basically, material is subject to compression, right? Material material is almost almost subjected to almost subjected to compression, right? Here, material is almost subjected to compression. So because of the compression in this zone, what happens? Because of the compression, a shear force, a shear stress is developed in different direction. Because of that, what is going to happen? A shear is going to develop in a different direction. What a shear is, right? A shear stress which is developed, shear stress which is developed in a so because right so because because of the compression because of the compression because of the compression, right? Shear stress is up, shear stress is developed, shear stress is developed in different direction, different different direction, right? Different direction. Apart from this direction, a shear stress what up, so deformation what take place, right? Formation what are the point your mind, right? Your mind basically when the because of that shear stress. Now what is going to be happen because of this shear? What is going to occur? occur Try to understand, right? Now what is going to be happen? Now you have seen that there will be a shear. This is what a shear zone, right? What a right. This is the shear zone. So basically here. So I am going to explain here, my dear. So whatever be the crystal, whatever be the crystal, whatever be the crystal is going to break, right? Is going to fail in. Now let's try to understand the mechanism, right? Let's try to the mechanism. Let's try to understand mechanism of chip formation. Mechanism of chip formation. Chip formation, right? Great. Right. In but here try to when the tool is going to apply the load, the tool going to apply the load, the tool, the help of this, right? The help of apply the load, then what is let me the point? Basically apply the load. Okay, in this zone, what is going to happen? Let me explain. Basically, a crack is going to right. A crack is to develop. A crack is going the crack as you can see, right? So this is the crack as you can see. This is going to what develop. Let me make it properly. The crack is going to be what develop here, right? The crack. Now this is the crack you can see, and because this is a brittle material, so crack will propagate, right? And this material get what get separated. This material get what get separated, right? This material get what get separated. So here these the tool. This is the tool, the tool, right? This is the tool. Here you can see. Here you can the the separated material get okay move. The separated material get moved, right? The separated material get moved along the face of. Now again, what is going to happen basically? Okay, let me make it with the red color because it is now again the chip again the tip of the tool, right? Again, the tip of the tool basically apply a load, and this load basically because of this load, a crack is going to be the crack is this will be separated. What this will be separated from the material, right? So similar thing will be going happen, okay, during the machine of brittle material. So that's why in the brittle material, a discontinuous what produces, right? So let's try to understand basically here the chip which is going to be formed here, the chip which is that are what write down types of chip, right? Let me write down types of. So here let's try to understand the types of right types of. So the first type of chip is generally is continuous. The second type of chip is what discontinuous. Discontinuous. Right. The third type of chip is what continuous chip with built up edge. Continuous chip with built up, right? So in this lecture we will try to understand of chip, try to understand this type of chip continuous with. So let's start with the discontinuous, my dear student. Basically, discontinuous chip are of two of regular size, okay, of regular size, and so let me write down here the discontinuous are of two. One is regular shape and size, one is irregular. or I will write here. First is of irregular size and of irregular shape and irregular irregular LAR irregular size and irregular size and right, irregular size and now my dear, irregular size and the what is the thing basically, the shape and size of every chip is what different. Okay, the shape and size of all the chip are not same. Basically, they are what? They are of different. And it will be when the work material is brittle, right? When the work material is brittle, right? When the work material are like cast iron, your machine of cast iron, then irregular shape size of chip are going to what produces. The second type which I was telling is the second shape I was telling is B of B of regular size and shape, right? Of regular shape and size. Regular. Now, my dear, here when the chip are of regular shape and size, here of irregular shape and size, the meaning that the chip which are going to be every chip of different every chip of regular shape and size means every chips are of almost same size, right? Almost same shape and so for that the work material should be for that your work material should be a for that work work material the material which you are going to do a machine work material ductile work material what ductile but hold on ductile is not because already you know when the workpiece is ductile in that case what is happen in that case generally in that case basically generally your continuous step is going to be get produces now. So along with the ductile the workpiece must be hard and hardenable, right? Ductile but hard and work hardenable, ductile but but hard and work hardenable and work hardenable work hard right? Ductile but hard and work hard nipple, right? Along with that, what you have to provide? Let's say this is the condition A. Let's say this is a condition first. Okay, for this case, now for the second, okay, second condition for this that the feed should be large, right? The feed should be large feed, large, right? Large feed. Now, you may be surprised, sir, because of large feed, what is happened? My dear, because of the large feed, basically chip thickness get increases. If the chip thickness get increases, then 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 there is a chance that chip get break, right? Along with that, workpiece is hardenable. It is ductile and work hardenable, so it is possible that it will break in a regular interval of time, right? Third condition should be your rake angle should be negative. Tool rake angle, tool, okay, rake angle, tool rake angle should be what? Should be right? Should be what? Should be negative. Now, Because of negative rake angle, what is going to be happen? Because of negative rake angle, the chip is going to be bent, and a large bending stress going to be produces in the in the in the deformation zone, right? In the deformation zone. Let me show you what is going to be happen basically. Suppose that this is the tool, right? Suppose that rake angle is negative. Let's say this is the tool, right? Let's say this is the tool having a large rake, having a negative rake angle, right? Have a negative rake angle. As you can see, this is what negative rake angle. Now the chip get bent, my dear. Now the chip get bent, right? Now the chip get bent. So what is going to be happen here? Bending stress will become, and the chip will break because of the large, because of the negative rake angle. So these are the most important condition. Along with that, you can do one more thing. Along with that, you can provide insufficient and you I mean you can provide insufficient cutting fluid. You can provide insufficient cutting fluid. Because of that, what happened? The temperature get increases, and there will be a thermal failure in the cutting zone. There will be a thermal failure in the cutting zone, right? So these are the condition, my dear. Okay, these are the condition. Now let's try to understand. Let's try to understand continuous condition for forming continuous chip with built up edge. But before that, you have to understand that what is the built up edge, my dear, right? What is the built up edge? You have to understand. So let's try to understand the built up edge. Let's try to understand the built up edge, right? Let's try to understand the built up edge, right? Condition of built up edge formation. Condition of built up edge formation. Built up edge formation. So here I'm going to write built up, UIL. Okay, here I'm writing built up edges, built up edge, right? Built up edge, built up, in short, BUE, right? Built up edge for built up edge. Now, my dear, built up edge formation. Try to understand. Basically, what is going to be happen now in machining tactile material, where continuous chip get produced. Already you know that if we are doing a machining operation, suppose that I'm doing a machining, right? I'm doing a machining, right? This is my tool, as you can see on your picture, on your screen. Now when you are machining a when you are machining a ductile material, then there will be a continuous chip formation. Then there will be a continuous chip formation. Look, so this is it. This is the chip which is produces continuous when you are machining a ductile workpiece. So what is going to be happen? A continuous rubbing will be take place in between the freshly prepared chip and the tool place. A continuous rubbing will be take place in between the freshly prepared chip and the clean face. Right. And already you know that at the tip, lot of, already you know at the tip or at the secondary deformation zone, there are lot of stresses come. There are lot of stresses will come. So because of that, what happened? A fresh material, a plastically deformed material, a plastically deformed material get stick at the tip of the tool. Right. So here, don't worry, I'm going to write each and everything in the language form. In machining ductile material, right? In machining, machining ductile material, in machining ductile material, right? Machining ductile material with long chip tool contact, with long chip tool contact with long chip to contact, okay, with long chip with long chip tool contact length, right? What is going to be happen? Lot of stress and temperature develop. Lot of stress and and temperature get develop get develops, right? Get develops in the secondary deformation zone. In the secondary secondary deformation zone. The secondary deformation zone, right? In the secondary deformation zone at the chip tool interface. The chip tool, the chip tool, right? So what happened at the at this tool, right? At this tool, no? At this tool tip, at this tool tip, right? The material get stick, right? The material get stick. Going to be what is right in the secondary deformation. What is going to be happen? Please try to understand secondary deformation zone. In the secondary deformation zone, lot of stresses and temperature get increases, and because of lot of temperature and stresses, okay, the plastically deformed material get stick, right? Get stick. So I hope you are getting my point, what I want to explain. So basically, under such high stress and temperature in between, under such high stress and temperature in between two clean surfaces of metal, in between two clean surfaces of metal, a strong bonding may locally take place. A strong bonding may locally take place, right? Due to you can say adhesion, due to adhesion, similar to welding, similar to welding. So here I'm going to write down. Please try to understand this point. Okay, please try to understand this point. So, my dear, what I was saying that under such high stress, right? Here, such high is under such high is under such high stress, high stress, under such high stress and temperature, high stress and temperature, right? Under such high stress and temperature in between two clean surface, in between two clean surfaces, right? In between two clean surfaces, okay, in between two clean of metals, of metals, right, of metals, a strong bonding may locally take, a strong bonding may, strong bonding may locally takes place, right? A strong bonding may locally takes place, right? Strong bonding may locally take place due to adhesion, similar to welding. Due to adhesion, similar to welding, right? Similar to similar to welding, similar to. So this is the built-up edge, right? So this is what, this is the built-up edge, right? Now When the cutting velocity is low, right? Suppose that the cutting velocity is low, right? Suppose that the cutting velocity is low, then sufficient time will take place for the formation of built up edge, right? So this is a built up edge, right? The disadvantage of built up edge is that here the rake angle get decreases. If the rake angle get decreases, then overall your cutting force get increases, right? And in a regular interval of time, and a regular interval of time, built up edge get will break down. Okay, will break down, and all of a sudden cutting force get decreases, right? Again, cutting force increases due to the formation of built up edge. So there will be a vibration. There will be a vibration which get produces. Okay, in this process, vibration get produces in this process, and this vibration is not healthy for the machining. Right? These vibrations are not healthy for this machining. And are you getting my point? These vibrations are not healthy due to for good for the machining condition. Right? You know, such bonding, these type of bonding will be encouraged and accelerate. Such bonding will be encouraged and accelerated if the chip tool material have a mutual affinity or solubility. Means the chip and tool, chip and tool suppose that tool is what? Iron base, right? Iron base, iron base material or ferrous base. Let's say it is what? It is a ferrous base. Is a ferrous base, right? It is a ferrous, and it is also what? A ferrous. It is also of ferrous. Then then the bonding acceleration get encouraged, right? Such bonding will be encouraged and accelerated if the chip tool material have mutual affinity or solubility. So let me write down this point. Try to understand. Such bonding will be encouraged. Such bonding, such bonding, right? Such bonding will be encouraged and accelerated. Will be encouraged and and accelerated will be encouraged and accelerated if the chip tool material, if the chip tool, right? If the chip tool material have mutual affinity. If the chip tool material have mutual, okay, mutual what? Mutual affinity, right? Mutual affinity, right? Mutual affi, right? So this is the, so try to get this thing, right? Try to get this thing, and slowly what is going to be happen? The weld material start forming, right? Suppose that this is the tool. You have seen that at the starting you have seen that some material get stick. The starting material which get stick at the tool tip, the starting material which get stick at the tool tip, that material is known as embryo. The weld material start forming as an embryo at the most favorable location and thus gradually grow. Suppose that this is what? Embryo, right? This is what? This is the embryo, embryo. This is what? This is embryo, embryo, right? Embryo, and that get accelerated and that get grow on that location. That get grow on that get grow at that location, right? And it will get grow at that location, right? So this basically this will act as a wedge. My dear, the initial rake angle, look, this was the reference line, if I'm not wrong. Initially the chip was flowing right on that way. The effective break phase of the tool is this. But after the formation, right? Try to understand this thing. Initially, the chip was flowing on that surface, right? But after the formation of built up edge, right, the wedge is going to be formed, right? The wedge is going to be formed. And because of this wedge, because of this shape of built up edge, the chip will flow like this, right? The chip will flow like this, my dear. The chip will flow like this, right? The chip will flow like this. So here, the effective rake surface, the effective rake surface, see, this is the effective rake surface, as you can see. Now, this was the effective rake surface, right? And that rake surface makes an angle, that is, and that rake surface makes an angle alpha, and this is what? This is alpha dash. And here you can see that your alpha dash is less than alpha. So the cutting force, right? Cutting force get increases compared to the initial value of the cutting force. So you can say with the growth of built up edge, you can say with the growth of built up edge, my dear, the force also gradually increases. The force also gradually increases due to wedging action. This is the wedge, right? Overall, you can say this is the wedging action. Okay, we can say that this thing is known as wedging action, right? Wedging action. This is known as wedging action, right? Due to which a wedge get formed, and because of that wedge, the overall rake angle get decreased, right, at the tool tip, right? So I hope this point is crystal clear to you people. Now let's move to the next point. Now what is going to be happen, my dear? My dear, as the cutting force increases, it means the reaction force which comes at the tool tip. This was the reaction force R dash, let's say. Initially, reaction force is R. So R dash also increases compared to R, right? Now, this reaction force, if this reaction force, here I told you there will be a micro welding. There will be what? There will be a micro welding. There will be a micro welding, as you can see. There will be a micro welding, micro welding, micro welding. There will be a micro welding, right? Micro welding, like micro welding. Let's say micro welding force. Now, my dear, if that reaction force, which the increased value of reaction force, if the increased value of the reaction force, if it is greater than micro welding force, micro welding, which is in between the plastically deformed material and the tool rake surface, then what happens? The built up edge will taken away by the flowing chip. The built up edge will be taken away. Okay, the PUE, the PUE will, okay, be taken away. The BU, the built up edge taken away by the flowing chip, by the flowing chip, by the flowing chip, right? The built up edge get broken away by the flowing chip. Again, if the built up edge get removed, the effective rake surface of the tool will be look like this. This is the effective tool. Again, you can see. Now again, if the tool is like this, now again, if the tool is like this, right? If the tool is like this is the tool, right? This is the tool. And again here, you can see that, right? You can see that this is again, this will be again your rake angle. Again, cutting force get decreases, right? So due to the formation and breaking of the built up edge, vibration get produced, right? Because this built up edge it again start form. Okay, then again start forming and grow. Okay, then after that, what is going to be happen? Then again, then again, built up edge QE. Then again built up edge, built up edge, built up. Then again built up edge start forming and growing. Built up edge start, built up edge starts forming and growing. Starts forming and and growing. Built up edge starts forming and growing. Right. Then again built up edge start forming and growing. Right. Which can produce vibration in the system. Which can produce vibration in the system. Right. Or conclusively you can write it will produce vibration in the system. It will produce vibration vibration in the system. Vibration the right, which is not good. Right. So this is the overall conclusion. Right. This is the overall conclusion. Right. This is what? This is the overall conclusion. So which is not good. So overall we can say that built up edge is not good for the machining operation. So I hope you understand the formation of built up edge. So now we can discuss that continuous strip with built up edge. How can we get the continuous strip with built up edge? Right? How can we get the how can we get just a minute? How can we get the continuous strip, okay, with built up edge? My dear, first of all, first of all, condition for forming continuous chips with built-up edge or without built-up edge. Let me understand. Let me explain you with built-up edge. Continuous chip with built-up. First of all, your workpiece must be what? Your workpiece. Your workpiece must be what? Tactile. It must be tactile, right? It must be what? It must be tactile. Cutting velocity, the cutting velocity, okay, which use should be medium. So this is the cutting velocity. Cutting velocity, cutting velocity should be medium. If you get decrease the cutting velocity, then what happen? Sufficient time will be available for the micro welding or for the bonding, then built-up edge get start forming very rapidly. Right. So you keep your feed medium. Okay. A minimum feed, minimum you keep your cutting velocity medium. Cutting velocity should be minimum. If you keep at the higher end, then the built-up edge not have a then the built-up edge will not form because sufficient time will not available for the micro welding. Right. The next is what? Feed should, if the feed is low, I told you, if the feed is high, then what happens? My dear, if the feed is high, then the cutting force get increased. And if the cutting forces increases, then the temperature get also increased. The temperature get increases, then temperature and the pressure at the tool tip is sufficient for the micro welding. So it is necessary that the temperature, at least you can reduce the temperature if you can. So you keep the feed, okay, at least minimum, the minimum at least your feed should be what? You keep your feed low, then it is good. But at least keep that optimum feed. Okay, keep that minimum feed. That is what meat. Here, right? Sorry, we are talking about the with built-up edge, na? Okay, with built-up edge. I was telling that if the cutting velocity is high, then sufficient time is not available. Right? If the cutting velocity is low, if the cutting velocity is what? Low, then the sufficient time is very much available. Right? Lot of sufficient time is available. If you keep the cutting velocity medium, then it get start forming. If you keep the cutting velocity low, then it will form very fast. Then built up edge form very fast. If you keep the feed if you keep the feed high, then what happen? Built up edge form built up edge formation is very rapid, right? If you keep feed low, then the formation of built up edge is what? Formation of built up edge is minimum. But if you keep your feed medium, then what happen now? Your built up edge get start at this stage, right? Get start at this stage, right? So this is the condition when the built up edge get starts, right? Also, you should supply the cutting fluid, okay, which is absent or inadequate. So here the cutting fluid, here the cutting fluid, here the cutting fluid must be what? Cutting fluid must be absent or inadequate, right? Absent or in okay, absent or inadequate, right? Inadequate, absent or inadequate, right? So this is a thing I hope you understand, right? This is a thing I hope you understand very well, right? This is a thing I hope now you can understand. Now, my dear, now let's try to understand the condition of what? Condition of without built-up edge, right? Without built-up edge. Now, the without built-up edge is very simple. Your work material should be what? Your your work material, at least it must be ductile. At least it must be ductile, and cutting velocity should be high. Cutting velocity high. Your feed should be low. Feed should be low. Right? Feed should be low. And rake angle must be positive and high. Rake angle, rake angle must be positive, high. Positive and high. Rake angle must be positive and high. And you should use a cutting fluid. Use a cutting fluid which are of both cooling and lubricating. Both cooling and lubricating. Lubri, both cooling and lubricating, right? Both cooling and lubricating. So these are the conditions, right? And I hope you understand the formation of what? Built up edge. Now, if you talk about me, sir, the effects of built up edge, right? If you talk about the effect of built up edge, right? If you talk about the effect of built up edge formation, the effect may be of two types, a harmful effect and a good effect, right? So let me write down the effect of B, right? The effect of BUE, right? Effects of BUE formation. Effects of BUE formation. The effects of BUE formation. Right. Now there will be two types of, like a harmful effect and a good effect. So let's talk about the good effect. Maybe you people are curious that, sir, there will be a good effect also. Yes, every coin have two sides. Okay, so here also built up edge have a good effect and harmful effect. Now you have to decide which effect is, which effect have a more weightage. If you're talking about the good effect, you are talking about the good effect, right? If you're talking about the good effect, the good effect is that, as you can see, at the tip the built up edge get formed. So this built up edge, because of this built up edge, the tip of the tool is not going to take participate in the cutting operation, right? Is not going to take participate in the cutting operation. So what happened now? What happened? The tip is safe. The tip is safe. Okay, the tip is safe. So built up edge protect the cutting edge of the tool. You can write that good effect is that built up edge get protect the built up edge get get protect protect the built up edge get protect the cutting edge of the tool, get protect the cutting edge of the tool. Cutting edge of the tool, right? Cutting edge of the tool. Maybe you may be surprised. Oh my God, sir! It means what? It means the tool life increases, my dear. Please think. Please, please recall the first lecture. What is the meaning of machining? Machining itself known as a finishing operation. Due to the formation of built-up edge, my dear, due to the formation of built-up edge, the actual cutting is not taken by the cutting edge. The actual cutting is going to be taken by what? Built-up, and built-up edge is plastically deformed material. BUE basically, UE is what? That built-up edge, or I can write this, that built-up edge, my dear. This built-up edge, right? This built-up edge, plastically deformed material. Plastically deformed material. Right, plastically deformed material. Plastically deformed. My dear, if this is a plastically deformed material, right? If this is a plastically deformed material, then what happened? It is harder than the workpiece which is going to be machined. Then during machining, what is going to be happen now? This plastically deformed material is more harder than the workpiece, then it will do a scratches. Then it will do a scratches on the surface finish get right. So your machining goal get what? Deviated. You are not getting the goal of the machining. You are not getting the goal of what? Goal of the machining. So harmful effect, let me write down the harmful effect. The harmful effect is what? The harmful effect is very simple. That is what? Poor surface finish, right? Poor surface poor surface, right? Poor surface. Also, you have seen that rake angle are get unfavorably changed, right? Unfavorable changes of rake angle, and because of unfavorable changes of rake angle, what is going to be happen? The cutting force get changed, right? The cutting force get changes, right? The cutting force get changes. The cutting force get vary. So here power consumption get vary. So it unfavorably changes the rake angle. Let me write down it unfavorably unfavorably changes changes rake angle, right? Rake angle. It unfavorably changes the rake angle at the tool tip, right? At tool the tool tip, the tool tip, right? At the tool tip, causing increase of cutting force, causing increase of cutting force, causing increase of cutting force, right? Causing increase of cutting force, that is power consumption, that is power consumption, that is power consumption, right? So overall, you can say it induce vibration. It induce vibration, and vibration is not good for the system. As you know, the vibration is not good for the system. So overall, we can conclude that built-up edge is not good, right? So the another question is that, sir, how can we eliminate? How can we reduce the formation of built-up edge? Another question is that how can we eliminate, right? How can we how can we reduce or eliminate of built-up edge? Reduction or elimination of reduction or elimination of built-up edge. My dear, how can we reduce? How can we eliminate the formation of what? Built-up edge. You should increase some parameter. you should some parameter. And what are the parameters? You should increase the cutting velocity, right? Cutting is the cutting is right. First, you should increase the rake angle. Okay, you the rake angle. Now, my dear, you should decrease. You should decrease some parameter. And what are they? The first parameter is feet, right? The first parameter is what? Feet. Depth of cut. Depth of cut. You should what? You should decrease. And you should use you should use the cutting fluid. You should use what? Cutting fluid, right? Cutting should use cutting. Now this cutting fluid, okay, this cutting fluid must be act as both lubricant and cooling. And if it is possible, then change the cutting tool material and do some coating on the tool, so that adhesion, so that the stickiness of the plastically deformed material will not take, right, will not take place. My dear, if you see the built up edge formation in case of rough machining, then it is good, because in rough machining our aim is not to get the good surface finish and good dimension finish, right? Our aim is not to produce a good dimension and surface finish. So in rough machining, the formation of built up edge is what is good, right? Sometime what happen, we will use the chip brick, right? We will use the chip brick. My dear, there is a disadvantage. Sometime there will be a disadvantage of this continuous chip. Sorry, there will be a one disadvantage of the continuous, or one or two disadvantage of the continuous chip. The disadvantage is because the chip is continuous, and the chip is continuous because it is thin, so the chip is sharp. The chip is what? So the chip is sharp. So there will be a chance that the worker may get, okay, the worker may the maybe the may the worker will maybe there is a damage, or there is a dangerous for worker. So there will be a problem with a continuous chip. Number one, it is dangerous to the operator, right? Continuous chip is dangerous to operate, right? Continuous chip is dangerous to operator. Sometime a coil of continuous chip, sometime it will come in the machining zone. And if it will come in the machining zone, then sometime that continuous chip get damaged the surface. Okay, overall I told you that the chip, there is a continuous chip which is sharp and hot, so it is very difficult to dispose the continuous chip. It is very difficult to dispose the continuous chip, right? So what is the problem? Basically, I told you the problem of continuous chip. Let me write down in very hurry manner. Okay, problem of continuous chip, continuous chip, problem of continuous, problem of continuous chip. Number one problem, danger to the operator, danger to the operator, to the operator, right? Danger to the operator. Number two, damage to the finished surface, damage to the finished surface, finished surface. Number three, difficult difficulties in chip disposal, difficulties in chip disposal, chip disposal, right? So there is a solution. There is a solution of chip breaker. So what we do, we are going to install a chip breaker. This is the chip breaker, my dear. You can see this is what this is a this is what this is the chip right? This is the chip. Now, because of chip breaker, what happened now? Whatever chip is going to be produced, right? Whatever chip is going to be produced, the chip get bent, right? The chip get bent, and at the tip, the chip seems to like at the tip, the chip is seems to like be a continuous chip. But when it move in a upward direction, because of the chip breaker, there will be a bending strain. There will be a bending strain, and the chip will get break from here. So from here, the chip will a discontinuous, but at the tip, the chip will seems like a discontinuous, right? So this is the good option, right? That's why we recommend generally a chip breaker. This is what a chip breaker. Okay, this is what the chip breaker, which overcome these disadvantage, right? Which overcome these disadvantage, right? So I hope you understand the thing. Thank you very much for this session. Okay, bye.